Hello everybody, this is Mr. Yen, and in this video I'm going to be guiding you through lesson 8.2a, where we are going to be talking about congruent and parallel line segments. Here's first some key vocabulary and concepts that you're going to be using in this lesson. Two line segments are congruent if they have the same length. So remember, congruent, in this case, for line segments, we think about length. Let's take a look at these two lines. Line segment AB, to figure out the length of this, it's a horizontal line, so we can just look at the difference in the two x values of the 2 points. So this is going from an x of -4 all the way to an x of 2. So that is a difference of 6. So I can say that the length of AB is equal to 6. If you have a grid, in this case, if it's going horizontally, you can also just count the units. 1, 2, 3, 4, 5, 6. Next, the length of CD. That's this line segment right here. And since it's going vertically, we can look at the difference between the two y values of the points. So this is going from a y of 3 down to a y of -3. So from +3 to -3, that's a total difference of 6. We can also just count the units, 1, 2, 3, 4, 5, 6. So the length of CD is also 6. Since we know that they have the two same lengths, therefore, we can say that line segment AB is congruent to line segment CD. And we always need a because. We need to say why. Because they have the same length. And we provided the evidence for them having the same length right up here, where we listed the lengths of the two sides. Okay, congruent, same length. Not to be confused with parallel. Two line segments are parallel if they have the same slope. So to see if two lines are parallel, we don't need to know anything about their lengths. We just have to know about their slope. That's how we can determine if they are continuing on forever, that they would never touch their parallel, same slope. So let's take a look at our two lines. Slope of AB. So that's going from here to here. Since we have a grid and the points are going between whole numbers, we can use a slope triangle. So it's going down 1, 2, 3 and across 1, 2, 3, 4, 5, 6. So change in y is 3. Change in x is going from -4 to 2, 6. So the slope of AB is 3/6. Now we have to check if it's positive or negative. Notice how looking from left to right, we're going downhill. So the change in y is negative. We're going down and then to the right. So I'm going to say it's a slope of -3/6. Okay, then I check, can we simplify? Is there some number, is there a common factor that I can divide into 3 that I can also divide evenly into 6? I can divide both of these numbers by 3. So 3 divided by 3 is 1. 6 divided by 3 is 2. So my slope of AB is -1/2. Let's take a look. And we can also see that slope of -1/2 right here. All these little smaller slope triangles are also making slopes of -1/2. down 1 across 2. Let's check the slope of CD. Going from C to D, it's this line here. If I make a slope triangle, I can see that we're going down 1, 2, 3, 4, and across 1, 2, 3, 4, 5, 6, 7, 8. I can also get those distances by comparing the difference between the y values and the difference between the x values of the 2 points. So my slope is 4/8, and I know it's a negative slope because going from left to right, I'm going downhill. Negative 4/8, I can simplify that by dividing both the numerator and the denominator by 4. 4 divided by 4 is -1. 8 divided by 4 is 2, so -1/2. And we can see that these two lines, they both have a slope of -1/2. They have the same slope. Therefore, the conclusion I can make is line segment AB is parallel to. So this right here is the parallel symbol that we can use. It's like 2 train tracks where both lines are running parallel to each other. So line segment AB is parallel to line segment CD. And we know that it's parallel because they have the same slope. Okay, so to recap, congruent, same length. Parallel, same slope. Let's look at one example together. Here's example number 1. This is page 2 of the worksheet. You have these 2 line segments, AB and CD. And the first thing we have to do is find the slopes of the 2 lines and then the lengths of the 2 lines. So let's start by doing that. AB, so from here to here, that slope, well, I can make a slope triangle. 1, 2, 3, 4, 5, 6, and 1, 2. So the slope is, the change in y is 2, the change in x is 6. Looking from left to right, this line is going uphill, so I know it's a positive slope. So I'm going to keep it positive. 2/6, I can divide both of those by 2, so I can simplify it to 1/3. Okay, CD. All right, I can make a slope triangle. We're going 1, 2, 3, 4, 5, 6, 7, 8, 9. So change in x is 9. Change in y, 1, 2, 3. So my slope, change in y is 3. Change in x is 9. Slope is positive 3/9 because we're going uphill, looking from left to right. We can divide both of these numbers by 3. 3 divided by 3 is 1. 9 divided by 3 is 3. So my slope is 1/3 for that line. Length of AB, well, I can go back here and look at my slope triangle. Right? And slope triangles are always right triangles, so I can use the Pythagorean theorem to find the length of this hypotenuse right here. So this length, let's just call it h, because it's the hypotenuse. So I know that hypotenuse squared is equal to the length of one of the legs squared, which is 2 squared, plus the length of the other leg squared, which is 6. So h squared is equal to 2 squared is 2 times itself. 2 times 2 is 4, plus 6 squared, 6 times itself. 6 times 6 is 36. And so I know that h squared is equal to 40, 6 plus 36. And so if I want h all by itself, to undo squaring, I'm going to take the square root of both sides. So then h is equal to the square root of 40. And then now, actually, I can say, instead of h, AB. The length of AB is equal to the square root of 40. The square root of 40 is not a perfect square, so then I can leave it just in square root form like that. Now to find the length of CD, I can use the Pythagorean theorem again. Let's say hypotenuse squared is equal to, this time we have legs of 3 and a leg of 9. So 3 squared plus 9 squared, h squared is equal to 3 squared is 9 plus 9 squared, 9 times itself is 81. So h squared is equal to 9 plus 81, which is 90. So then I know that the length of CD is, if I take the square root of both of these, square root of 90. Okay. So now I have the slopes of the two lines and the lengths of the two lines. First, are the line segments parallel? Parallel, same slope. Let's check. This has a slope of 1/3. This has a slope of 1/3. We can conclude they're parallel. So I will say AB is parallel to CD because they have the same slope. Then, are they congruent? Congruent, same length. Let's check. Length of AB was the square root of 40. Length of CD was the square root of 90. Those are obviously not the same number, so they're not the same length. So I'm going to say AB is not congruent to CD because they have different lengths. So that's how you can prove or disprove that things are congruent or parallel. And with that, that's everything you need to know. So I will say goodbye and good luck.